Hey everyone, I'm gonna share my screen. Cool, can everyone see that? So since last week, we've sort of finished up a lot of the stuff on the fungible token library. So this is a library that will help people write native actors that implement the token standard, which now has a FRC number. So Alex North has recently landed that FRC46. And so we've got this Rust sort of library to help do that. And now that that's sort of more finalized, we've published a example actor. And so this basically is just the minimal set of methods on an actor that will fulfill that interface. And right now, basically, if you call this actor, if you call the mint function on this actor, it'll just give you some number of tokens. So this is purely sort of for example use, shouldn't be deployed on a real chain ever, but basically sort of lets us figure out that everything's working, and sort of it's the first time we've sort of been able to call it with a receiving actor, because part of the standard is that sort of all receiving actors need to implement a hook and accept all incoming transfers. And that was sort of the big idea here, was to sort of avoid this problem with ERC20s on the Ethereum network, where people were accidentally sending funds to smart contracts that were unable to sort of deal with them or didn't know about them, and they would sort of essentially lose their funds once they were locked into those smart contracts. Apart from that, we've also been doing a library implementation for another FRC. FRC42 is for conventional method names for contract-to-contract calls. And so for example, for our token standard, we need the transfer and balance of sort of all these methods to be found at predictable method numbers. And so FRC42 is a specification of how sort of method names translate or are hashed to become method numbers. And so we've published a crate called FRC42 Dispatch, which basically gives two macros that let you calculate these method numbers at compile time. So the first one is this match method macro, which is sort of used in your invoke function. You take in the match, and this generates it converts these names into method numbers, and you can handle them as you need to. And then on the other side for callers, there's also a macro that just takes in the string and returns the number. And so that's what you'll use to sort of call or get the method numbers for methods that you wish to call. So that's sort of wrap up of work that's been going on previously. Moving forward, we're looking at starting some discussion and implementation around NFTs. So we've started a Slack channel to sort of foster discussion around this. And we were originally going with this idea of a clone of FRC721. And so that's the standard NFT implementation on Ethereum. But we did a bit more thinking recently, and so other chains such as Solana, and sort of with the token library and our fungible token standard that we've built, we've essentially got all the functionality of an NFT already by sort of minting fungible tokens that only have a unit balance. So if you're not allowed to mint any more tokens once it exists, and you can't transfer fractional tokens, then it essentially acts as a non-fungible token. And so if we use that as a building block and sort of have this abstraction of a collection on top of that, then we sort of are able to approach this sort of NFT pattern that exists in other chains sort of in a different way. Because sort of NFTs on an NFT contract on Ethereum might serve two purposes. So one is to sort of mint and keep track of these tokens, but also a single contract tends to hold a collection of related tokens. So if you're familiar with sort of the digital art NFTs, all of the Bored Ape NFTs would exist at one address. And so these NFTs contracts are actually serving sort of this secondary purpose of grouping and collecting related NFTs. And so we have this alternate proposal in discussion that sort of essentially says, if we introduce a separate standard for collections of actors or smart contracts that sort of expose the same interface, then we could implement an NFT standard by sort of having a collection of FRC46s. And so we're currently looking through sort of what this would actually mean to do this on chain. But essentially the major difference would be sort of instead of minting an NFT into a single actor's state, you'd be instantiating a new actor on chain, which represents a new token. And so the most likely sort of conclusion of this, we think, is that it's going to be a bit too expensive gas-wise to instantiate a new actor every time we want to mint an NFT, especially because with NFTs, we can sort of save a lot of, there's optimization in sort of how we can lay out NFTs and sort of assumptions we make there that we can't do for fungible tokens. So the initial estimates we've got are that sort of doing it batched and sort of within the same actor is going to be about 10 times cheaper in gas. And so we're looking at sort of other avenues to sort of keep this high level idea, but sort of not waste as much gas sort of instantiating new actors. So that's active discussion going on now in the Slack channel. If you guys want to join that Slack channel and sort of share ideas or thoughts, that'd be awesome, as we're sort of in the early stages of figuring this out.